So we continue with validating arguments, and as you can see, we have this argument here. If you drive a Corvette, then you drive a sports car. You do not drive a Corvette, therefore you do not drive a sports car. And of course, before we build any truth tables to validate this, hopefully you get a sense, a logical sense of whether this argument is going to be valid or not. Just have an intuitive sense for it. But of course, we'll go ahead and we'll use our truth values, but let's point out our simple statement. You can see right here, you drive a Corvette. That is going to be our first simple statement. We'll just go ahead and label that as P. And of course, it says if you drive a Corvette, and then of course, then you drive a sports car. So here is our second simple statement. That's going to be Q. And of course, you could see that this is a conditional statement. So this is our first premise here. If you drive a Corvette, then you drive a sports car. As we continue on, you do not drive a Corvette. So this looks like this is going to be not P, and this, of course, is our second premise. Then you can see right here, therefore, this will be our conclusion. You do not drive a sports car, so this will be not Q. So symbolically, the way we would write this is our first premise, if P, then Q. Our second premise, not P. And then we separate the premises with this horizontal line here. And then we put in our conclusion, therefore, not Q. Now, our premises, both the first premise and the second premise, notice that I said and, the first premise and the second premise must be able to support our conclusion. So we'll go ahead and we'll build our truth tables according to that. But the first thing we'll do is we'll put in our standard values here, P and Q. So we'll have true, true, false, and false. And then true, false, true, false. Now we can see that we have a not P and we have a not Q. So we'll go ahead and we will list those right away. Here's not P and then not Q. And the negation turns a true statement into a false statement and vice versa. So this is going to be false, false, true, true. And then false, true, false, true. We'll go ahead and we'll build our first premise here. If P, then Q, which is a conditional statement. And then we know from a conditional statement that the antecedent has to be true and the consequent has to be false for the entire statement to be false. So here it is true right here and false right here. So here it's false. Other than that, it's going to be true. Then we have to make sure that the first premise and the second premise has to support our conclusion. So we'll build the truth table for the first premise, if P, then Q, and the second premise, not P. And of course, this winds up being a conjunction. And for a conjunction to be true, this has to be true, and this has to be true. So it's true here, and it's true here. It's true here, and it's true here. Other than that, we have falses. The next truth table will show the conclusion. So we have if P, then Q, and not P, and I like to say therefore not Q. That's our conclusion. And of course, this entire thing is a conditional statement. So this has to be true, and this has to be false for the entire thing to be false. So we have a true and a true here. So that's true. And we have a true, but we have a false here. So this winds up being false. The other values are going to be. So this is not a tautology. All the values would have to be true for this argument to be valid. But since we have one false truth value, this winds up being an invalid argument. And there you go.